When you're solving absolute value functions, there's only going to be so many different ways you can find solutions. So if you have one where you have an absolute value and a line, they're not touching at all, there'll be no solutions. When you have a line right on the x-axis and an absolute value, right touching it, those should touch, you'll have one solution. And when you have an absolute value function and a line going through it like that, you'll have two solutions. With quadratics, you can have a line and a quadratic, and they don't touch, so there's zero solutions. That does not say solutions. There we go. If you have a line right on the x-axis and an absolute value, you can have two solutions. If you have an absolute value and a line going above it, oops, it should touch this line. And it touches all 3 points there, you'll have 3 solutions. And if you have an absolute value and it goes through all of these points, you can have 4 solutions. So there's more solutions when you have quadratics. When you have an absolute value function, you want to solve it. First, we're going to graph the 2 lines that we have. So you're going to graph y equals 6, and you're going to graph y equals 3x minus 6. So y equals, oh, that's not a good example. One second. So if we graph it, I'm going to go up by 2's or 3's on the y-axis and over by 1's on the x-axis. So if we graph y equals 6, we'll have a straight horizontal line going through the point of 6. So those are all the values in which y is equal to 6. Now we're going to graph our absolute value function. So we have a point at -6 and a rise of 3 and over 1. Rise 3 over 1, rise 3 over 1, rise 3 over 1. So this is all going to be dotted, and this is straight, and we need to remember to reflect across our critical point. So there is our absolute value of 3x minus 6. So we have 2 points where it crosses, here and here. So the points are 4 and 6, and 0 and 6. To check, we're going to plug this into the equation. So we want x to equal 4 and y to equal, or x to equal 0. So if we plug them in, 6 is equal to 3 times 4 minus 6. 12 minus 6 is 6. This one works. 6 is equal to 3 times 0 minus 6, and of course this is the absolute value. So 6 is equal to the absolute value of -6. That's true, so they both work. So our answers are x equals 4 and x equals 0. For this one, we're going to graph y equals 3. So 1, 2, 3. So there's our first line. Now we're going to graph the parabola with a vertex of 0 and -3 and a stretch of 3, and it opens up. So we have 0 and -3, stretch of 3. So this is going to be dotted, and this is going to go up like this. And when we invert our vertex, it'll be at the absolute value of the vertex will be at 0 and 3. So right here is our points. So they cross here, here, and in the middle. As you can see, it's easy to tell the exact point right here. X is equal to 3. It's also equal to this and this. They should be closer to equal, but I didn't draw this very well. So if we were to make an estimate, I would say that's at about 1.4. So x could be 1.4 or negative 1.4. To check, we would sub this into the equation and see if it works. When we check these two numbers, we don't get the exact amount. And the reason is because our graphing is not perfect. Even if you were to use a graphing calculator, there'd be a bunch of decimals. So this isn't the best solution on how to solve for a quadratic, but it is a possibility. This 3 works perfectly. 3 is equal to the absolute value of 3 times 3 squared minus 3. 3 squared is 9. Just kidding. This is 0. X is not 0. Y is 3. Okay, so 3 times 3 is 3 times 0 is 0. Minus 3 is 3, absolute value. So these are close, but they're not exact. For the next one, if we were to graph this, our first line is at y equals negative 2. If you look at this, this is an absolute value function. Absolutely never will you have a function in the lower quadrants. It'll be somewhere up here, wherever it is. There's no way that it's going to touch this bottom area. So that means that there's no possible way this line and parabola will ever touch, so there's not going to be any solutions. And even if you just look at this, if a solution to an absolute value function is a negative, that just doesn't make sense. You can't get a negative. So this one, no solutions.